All right, so this video is going to go over pages 19 through 21. This is the conservation momentum assignment. So when we're doing this, remember there's three different scenarios as far as collisions go. Okay, you have where the objects are separate in the beginning. So you have, let's just say, a ball here, okay, and a ball here. They hit, okay, and then they remain different, okay, or remain separate. Okay, so that would be your type 1. So your equation would kind of look like this. It would be m1v1 plus m2v2 equals m1v1. That would be a final velocity plus m2v2 final velocity. Okay, so when you're reading these problems, you got to just make sure, set up what's happening before they hit. Okay, those are going to be your initial velocities. And then anything after, when they mention after it hits, that's going to be a final velocity. Okay, your type 2 would be something like this, is where you had, let's just say, a ball and another ball come together. They hit, and now they stick, and they're together as one. Okay, so your equation would kind of look like this. It would be m1v1 initial plus m2v2 initial. They come together, and now it's m total. Okay, so it's one mass now and one final velocity. Okay, so that'd be your type 2. Now, type 3 would be the opposite of type 2. So usually you have like an object, like you have one whole ball like this. Okay, and something happens where it splits apart. Okay, whether it be explosion. Okay, this is like usually the gun and the cannon problems. Okay, and now you have two separate objects going the other way, going different ways. So this would be an m total v initial equals m1 v1 final plus m2 v2 final. Okay, so those are your three scenarios there. Okay, so we're going to go through these problems and basically see what we have, and then we're going to set it up. So let me clear some room on here. All right, so on number 1, you have a 5,000 kilogram boxcar moving at 5.2 meters per second on a level frictionless track, runs into a stationary 8,000 kilogram tank car. If they hook together in the collision, how fast will they be moving afterwards? Okay, so it mentions that they stick together in the end. So I'm going to go through, I'm going to set this up. So this would be M1, this would be V1. Okay, so I have 5,000. Okay, it's going at 5.2 meters per second. Plus, this would be my M2, my 8,000 kilogram tank car. Okay, so its mass is 8,000. Okay, it says stationary, so watch out for words like that. So that means its velocity is 0. Equals, now they've hooked together and they're 1. So I'm going to take their masses and combine them. Okay, so this would be 13,000. And we want to know what the velocity is. So there's your VF. That's what we're looking for. So you're just going to solve for VF, and you should get a VF of 2 meters per second. Now, if you're doing the MVP way, I can show you. I'm not going to do this for every single problem, but this is the MVP way. Okay, so you would set up your mass. So this is left side would be before, right side would be after. Okay, so my mass, my first mass would be 5,000. Its velocity would be 5.2. Okay, then my mass 2 is 8,000. Okay, that velocity is 0. Okay, so what I would do is I would multiply my mass and my velocity. Let me pull out my calculator real quick. So 5,000 times 5.2. That gives me a momentum of 26,000 for that tank car. Now, 8,000 times 0 is 0. What I would do is I would add these up, and so that means I have a total momentum of 26,000. Okay, on my right side, well, now they've combined. Okay, so you can do them separate if you want to, or you can just do one, whereas now it's 13,000. Okay, V you don't know. Okay, so there's your X. Okay, so 13,000 times X is 13,000X. Now what you're going to do is you're going to set this equal to, you're going to set your left side total equal to your right side total, and your right side total will just be 13,000X. So 26,000 equals 13,000X. Divide both sides by 13,000, and you get 2 meters per second. Okay, so that's if you want to do the MVP way. Either way works. Okay, so I do the equation way, so I'll do a couple of MVPs on here, but mostly the equation stuff. Okay, number 2, a 75 kilogram girl is running at 3 meters per second, jumps onto a sled that has a mass of 10 kilograms, and that is already moving in the same direction as the girl at 2 meters per second. So as far as velocities go, I don't need to make anything negative because they're both going in the same direction. What will be the final velocity of the girl and the sled? Okay, so assuring that the sled is on a level snow and there's no friction. Okay, so you have a girl running Sled's going in the same direction. She jumps on the sled, and now they are together. Okay, so what we're going to do is we're going to set up our equation. So M1 would be 75, and she's moving at 3.0 meters per second, plus mass 2, 10 kilograms, and it's going in the same direction at 2 meters per second, equals, now they're together, so 75 plus 10 is going to give me 85. Okay, and then I don't know what their velocity is once they're together, so that's your VF. Okay, so find what VF is, and you should get VF equals 2.9 meters per second. So that'd be your answer there. 300-gram ball is moving at a constant velocity of 200 centimeters per second. Okay, so one is I can't have grams. I need kilograms, so divide by 1,000. Okay, so that's going to be 0.100 kilograms. Okay, I can't have centimeters per second, I need meters per second. So remember, there's 100 centimeters in a meter, so divide by 100. So you get 2 meters per second. Okay, strikes a 400-gram ball that is at rest. Okay, so 400-gram ball, so we need to divide that by 1,000. Okay, that becomes 0.400. Initially at rest, so there's your velocity there. After the collision, the first ball rebounds straight back at 120 meters per second. So key thing there is straight back. That means this is going to be negative. And I'm going to go ahead and divide that by 100, so that's 1.2 meters per second. Calculate the final velocity of the second ball. So that means they didn't stick. Okay, so this would be a ball plus a ball. They hit, and then they still remain separate. Okay, so M1 times V1, so 0.100, times velocity 1, which is 2. Okay, plus I have my M2 is 0.400, is at rest, so that's at 0, equals, so my 0.100 ball is still 0.100 kilograms. Okay, it rebounds back at 1.2, so this is going to be a negative 1.2, plus my 0.400 kilogram ball, and we don't know what the velocity of that is, so that's going to be your VF, what you're looking for. So simplify it, so we get 0.2 on the left side equals negative 0.12 on the right side plus 0.4 VF. Okay, so clean that up, solve for VF, and you get a VF of 0.8 meters per second. Okay, going on to number 4. Okay, a 25,000 gram object. Okay, so this is, we're going to fix that. Divide by 1,000, you get 25 kilograms. Is moving with a velocity of 3 meters per second to the right. Okay, so we'll pay attention to that. Collides with a 15 kilogram object that's moving to the left. All right, so we're going to make this negative. Find the velocity of the 25 kilogram object after the collision if the 15 kilogram object continues to move to the left, but only at 0.30 meters per second. So I didn't mention they stuck at all, so this is going to be where they're separate in the beginning and separate in the end. Okay, so you could do this. So mass 1, 25, times velocity 1, we're going to say that's positive, going to right is positive, plus a 15 kilogram object is moving to the left at 6, equals, so we're going to make that negative 6. Okay, they stay separate, so mass 1 is still 25. Velocity 1 says find the velocity 1 of the 25 kilogram object, so we don't know, so there's your x. Plus, my 15 kilogram object is moving to the left, but at 0.30, so it's negative 0.30. Okay, so you'd simplify that out, and you're going to get, so it'll be negative 15 on the left side equals 25x minus 4.5. So get x by itself, and you're going to get a value of negative 0.42 meters per second. Now, if you're going to do MVP trick, so you can do it that way. So MVP, MVP. Mass would be 25. Okay, velocity would be 3. Okay, so 25 times 3 is 75. Okay, then you'd have mass, so 15. And you'd have a negative 6. So 15 times 6 is going to give you 90. That's negative 90. So add that up. Okay, and you get negative 15 equals your left side. Now your mass is still 25. Okay, so then we don't know the velocity of the 25 kilogram mass, so that's x. So 25 times x is 25x. Okay, my second mass is still 15. That didn't change. Okay, it's going to the left at negative 0.3. Okay, so 15 times 0.3 can give you negative 4.5. So add those up, and you get 25x minus 4.5. So that becomes negative 15 equals 25x minus 4.5. So if you notice, it's the exact same thing as right here. Okay, so that's the way you do it MVP way. Now we're going to do the same thing, but now the 15 kilogram object rebounds to the right at 0.45 meters per second. Didn't mention it's stuck at all, so it's still separate, beginning separate after. So we're just going to go ahead and fill in what we know, 25 times 3 plus 15 times negative 6 equals 25. We still want to know what is the velocity of the 25 kilogram object, so that's x, plus my 15 kilogram object's now going to the right at 0.45, so that's a positive 0.45. Okay, and you're going to solve for x in this case, and you're going to get a final velocity of negative 0.87 meters per second. Now part C, it says now they stick together. Okay, so now they become 1 in the end. So our before didn't change, so it's still 25 going at 3 plus 15 times negative 6, but now they're stuck. Okay, so 25 times 15 is going to give me 40. I'm sorry, not times. Add, so 25 plus 15 gives me 40 times VF. Okay, so this is where they stick together. Now they just have one mass, one velocity. Divide both sides by 40, and you get a final velocity of negative 0.38 meters per second. Number 5, a 1.5 kilogram wooden trolley on wheels is stationary, so watch out for terms like that. Okay, so it means it's not moving. Okay, it's on a horizontal frictionless track. What will be the final velocity of the trolley if a bullet with a mass of 2 grams, okay, we're going to fix that. There's not a whole lot of room for that. So 2 divided by 1,000 is going to give you 0.002 kilograms. Okay, fired into it with a horizontal velocity of 300 meters per second along the direction of the track. The bullet remains embedded in the trolley. So that means they were separate in the beginning and they're stuck in the end. Okay, so this would be M1 times V1, so 1.5. The 1.5 kilogram trolley is sitting there doing nothing, so that's 0 for your velocity, plus my mass is 0.002 for the bullet. Okay, it's moving at 300 meters per second. Okay, equals, and now they're stuck. Okay, so now I'm going to combine their masses, so their masses would be 1.502. And we want to know what is the final velocity once they're stuck. Okay, so solve for VF, and you should get a final velocity of 0.40 meters per second. Okay, number 6. A 5 kilogram ball of putty moving at a speed of 6 meters per second strikes a 1.0 kilogram block of wood, which was initially at rest. The putty sticks to the wood. What is the final speed of the wood? Okay, so that means they've stuck together again. Okay, so they're going to be separate in the beginning, so 5.0 would be your mass. Okay, it's moving at a speed of 6 meters per second, so that's 6, plus hits a 1.0 kilogram block of wood, so 1.0 kilogram initially at rest, so that's going to be a velocity of 0, equals now they're stuck, so 5 plus 1 gives you 6, and now you want to know what the velocity is once they're stuck together, and you get a final velocity of 5 meters per second. Okay, number 7, a 10-gram bullet, divide that by 1,000, that's 0.01 kilograms, is fired with a speed of 1,000 meters per second from a freely hanging 2.0 kilogram gun. Okay, what is the recoil velocity of the gun? So freely hanging just means there's nothing holding it to prevent the recoil. Okay, so don't get too hung up on that. So that means they're together in the beginning and then they separate. Okay, so the mass is, both of them together would be 2.01. I just combined the bullet and the gun. Now before you fire the gun, it's not doing anything, so that's going to be 0. Okay, so this whole left side is going to be 0. Now they separate. Okay, so now you got the 0.01 kilogram bullet is moving 1,000 meters per second. Plus, now I've got the gun, which is 2.0 kilograms, and we don't know what the velocity of that is, so that is your VF. Okay, so clean that up, and you're going to get a final velocity of negative 5 meters per second. Now, a 5.0 kilogram body at rest is torn apart by an explosion, breaks into 2 pieces. A 4.0 kilogram piece is seen moved off to the right at 50 meters per second. Describe the motion of the remaining 1 kilogram piece. So this is just like the problem before. They're together in the beginning. Okay, so what some people are doing is they're seeing that there's 3 masses here. Well, it's technically 5 is the total mass, and it just broke into 2 pieces. One would be 4, one would be 1. So in the beginning, it was 5 kilograms, so there's your mass. Okay, it was sitting at rest, so that's 0. Okay, then it blows up and breaks into pieces, so one piece is 4 kilograms, and it's moving to the right at 50. Plus, the other one is 1, so 1 kilogram, and we don't know what that velocity is, so that's going to be our question mark. Okay, so clean this up, and you should get a velocity of negative 200 meters per second. Okay, last one, a 10,000 gram mass moving to the right, so we're going to divide that by 1,000, so that's 10 kilograms. Okay, is moving to the right at a speed of 20 meters per second, interacts with a second mass, which has initially moving to the left at 20 meters per second. After the interaction of both masses are found to be moving to the right at a speed of 5 meters per second, how large is the second mass? So in this case, it says they're both moving to the right at 5 meters per second after the interaction, so that means they're stuck. Okay, so this is going to be where they're separate in the beginning and then stuck in the end. So mass 1 is 10 kilograms. It's moving to the right at 20. Plus, interacts with a second mass. We don't know what M2 is, so we're just going to leave it as M2. It's moving to the left at 20, so that's negative 20. Okay, now they stick. Okay, so that would be M2 plus 10. Okay, so we combine those, and now they have a velocity moving to the right at 5. Okay, so I'm going to clean this up. So all I'll do is I'll bring this 5 in. Okay, 5 M2 plus 50 equals, and then you clean up this left side. So let me check this real quick. So this would be 200 minus 20 M2. Okay, so now what I'm doing is I want to get M2s together. Okay, so I'd move this negative 20 M2 over to the right. That becomes 25 M2. Okay, and then I would subtract 50 from both sides. That becomes 150. So 150 equals 25 M2. Divide both sides by 25, and you get a mass of 6 kilograms. And that'll end that one.